In the world of networking, the terms Layer 2 and Layer 3 switches often come into play. These are not just random numbers, but represent different functionalities in the grand scheme of network communication. Let's dive right in and dissect these important components. Layer 2, or the data link layer, is where switches usually operate. These switches are responsible for transporting data across a single network, or what we call a local area network, LAN. They identify devices on a network using MAC addresses, which are like unique fingerprints for every device. Layer 2 switches are experts in handling frames, the structured packages of data that zip around in a network. Layer 3 switches, on the other hand, are a bit more sophisticated. They operate not only on Layer 2 but also on Layer 3, the network layer. This is the layer that deals with packet forwarding, including routing through different networks. Layer 3 switches use IP addresses to guide data to its destination, making them a valuable asset in larger networks where there are multiple paths to choose from. There's a certain beauty in the way these two types of switches work together to make communication possible. Layer 2 switches create the perfect environment for data to travel within a network, while Layer 3 switches take the baton when it's time to move data between networks. Now let's talk about gateways. In networking, gateways serve as a bridge between two different networks. They are the metaphorical door between your local network and the vast expanse of the internet. Both Layer 2 and Layer 3 switches can function as gateways, but Layer 3 switches often take on this role due to their ability to route data. Next, we have the spanning tree protocol, a protocol that prevents loops in a network. Imagine being a piece of data, going round and round in a network without ever reaching your destination. Not a pleasant journey, right? That's exactly what the spanning tree protocol prevents. It helps to create a loop-free topology for Ethernet networks. Both Layer 2 and Layer 3 switches can support this protocol. Lastly, let's touch on broadcast domains. These are logical divisions in a network where if one device sends out a broadcast, all others in the domain will receive it. Layer 2 switches define broadcast domains. Each of its ports represents a separate broadcast domain. Layer 3 switches, however, can control broadcast traffic between its interfaces, making it possible to create multiple broadcast domains within a single switch. In conclusion, Layer 2 and Layer 3 switches are essential gears in the machine of network communication. They each have their roles, their strengths, and their abilities. Understanding them is key to mastering network infrastructure. So remember, Layer 2 switches for transporting data within a network, Layer 3 switches for routing data between networks, gateways as doors between networks, spanning tree protocol to prevent loops, and the concept of broadcast domains to understand data broadcast. Keep these key points in mind and the world of networking is yours to command.